Okay, so good morning, good afternoon, good evening, wherever you are located, okay, across the world. You are welcome once again to our lesson on binary operation. And we are looking at how to do evaluation under binary operation. So that will be, okay, our main activity for today, how to evaluate. And after that, we'll look at how to use our evaluation to determine commutativity, associativity, and distributivity of what binary operations. So straight away, quickly, let's look at our previous question. So the IV, this is what was this the assignment that I gave you? That some of you, yes, some of you I think forgot because I didn't put it on the platform. Okay, but those who got it from class submitted. So okay, as usual, this is what we are supposed to do. Okay, so this will be equal to an expression. We work on what we have in brackets. So you keep your -5 star, then come and work on what we have in brackets. Remember, the rule for star was, what was the rule? So let's go back to the rule. Okay.
A plus B plus 2.
A plus B plus 2, very good. So in that case, our A is -6. Oops, forgive me. Okay, so A will be -6. Okay, plus B, which is -9, then plus 2. Is that clear? And I've told you in your subject, you can put it in brackets. So this gives us -5 star. Okay, you ask yourself what you have in brackets. Can you combine and make it an element? Immediately the answer is yes. And it means when you are combining and you are writing, the brackets can now go. So you are going to get -16 -9, which gives us -15. Am I right? Okay, then plus 2. That will give us what? -13. -13. So it means now still you are combining two elements under a star. And the rule you said is what? Your A, which is your first term, so -5, plus, or did I say your first term, your first element, plus your B, which is your second element, -13, then plus what? Your 2. That's the rule. So that gives us -5 plus what? -13. So it's -5 -13, which gives us -18, then plus what? Plus 2. So that will give us minus what? Am I right? It will give us minus 16. Okay, so this is what so you comfortably come and draw your conclusion. Therefore, your -5 star, okay, minus star, -9 is equal to your -16. So some of you introduce some other, okay, steps that were not necessary. Some of you will combine this one, then come and write the value there. So maybe -17, then plus what? The 2, then 5 star that. Before you can combine this mentally, everything mentally, combine it mentally and move from here to here. Straight, just as we combine the whole of this mentally. So don't come and combine these two, then later go in. Okay, in our previous meeting, I said I was using that, okay, to break down my steps for you to relate. However, if you can combine addition and subtraction, anytime you can combine your terms mentally, combine mentally and write the entire value there. Am I clear? Okay, all right. So that will be it for, okay, our first set of questions. Now let's go and look at our second set of questions. Okay, again, we are still on evaluation. Okay, we are on the evaluation. Okay, so this is what we have. So a binary operation, so question 2, work example 2. Okay, binary operation delta is defined on a set R of real numbers by, okay, so this is what we have. So at this point, solution, our operation and its rule, if it is given, is very critical. And as well as what your set that your operation is what is defined on. So let's go and look at the solution to A. using this. So I go and so this information here, the operation and its rule, is a general information that we are going to use to answer all the questions under A and all the questions under B. Similar to what we just did. Only that this time around you can see some numbers which are not that pretty fractions, but it's the same concept that we are going to use. So at this point, question 2, okay, the information that you extracted here, you can see that where you have the information, the question number there is what? 2. So that's why you have 2 equally attached there. So 2, this was the information that I could extract. And in this case, remember it's X and Y belonging to what? R, because we were told that your operation is defined on a set of real numbers. So it means these 2 letters, X and Y, these 2 elements must also come from that. So in a way, instead of writing the end, you can equally write this. So please take note. You can write comma. Okay. So you can just write comma. Okay. Your Y. Okay. Belongs to what? R is the same thing. Is my point well made?
Yes, please.
Okay, so now we go and look at AI. AI, this is the peculiar information that we've extracted. So it's an expression we start with equal to. And anytime you are writing, we write close to the margin. So per the rule, look at the rule. The rule is saying that, okay, anytime you combine 2 elements and the delta, okay, your result, that's how you get it. Your first element plus the second element plus 3 times your first element times your second element. So don't change the nature of the rule. Go strictly by the rule. So if I come here, my first element is 1 over 2 and my second element is 2. Do you agree?
Yes.
So if I'm combining these 2 under the operation what? Delta, I am going to have my first element, which is 1 over 2, plus my second element, which is 2, plus what? 3 times my first element. My first element is 1 over 2. I put it in brackets. Then my next element is what? 2. I equally put it in brackets. Is that clear? Okay, so I follow the rule strictly. At this point, you don't have delta in play. So it means you are not under the rule for delta, but you are under the rule for algebra. And in algebraic expression, you go and work with what we have at the bracket first. So you have 1 over 2 plus what? You are going to remove the bracket. So you get your 2 will be there, then plus. If you are removing the bracket and you are multiplying, you know what to do. Okay, order of operation. So you multiply numerators, you check if you can reduce before you multiply, but we can't reduce, so you multiply. So this will give us 3 times 1 times 2. So I will get, can we reduce?
Yes, please.
Yes,
Okay,
please.
very good. So obviously, you know, these 2 can go here and cancel these 2. So now you can multiply and you get 3. So you can see that if you go and multiply before you reduce, you will write more. So always reduce before you, okay, multiply. So at this point, this is what we are going to do. I know some of you, okay, if not most of you, will take the LCM. Okay, however, once I have whole numbers, okay, and I have a fraction which is less than 1, I can always combine mentally. So I will do 2 plus 3, which is 5. 5 plus half will give me 5 and half. Is that not it? So I will just, because at the normal circumstance, I'm not supposed to conclude with an improper fraction. I have to change it to mixed fraction. So I'll straight away get 5 and half without struggle. Then I go and draw my conclusion. The person who takes the LCM will get the improper fraction version before changing it towards the mixed what numbers. Is my point well made?
Yes.
So always think before you write. Oh, sorry. Okay, start delta 2. This will be equal to 5 whole number 1 over 2. Is my point well made? Okay, so that will be
Yes,
it for
please.
I. We are going to look at II. It's the same concept. Remember the rule, x plus y plus 3xy. That is your first plus second, okay, plus the product of 3 times the product of your first and second. So that's what we are going to use here again. So however, you know, anytime your quantity is negative, you are compelled to put it in brackets wherever you want to write it. Okay, however, if you are smart, you know where you can ignore the bracket. So here we want to play safe. Our first is negative, so minus 1 over 3. Okay, at this point you can ignore. It won't be costly because its coefficient is 1. Then plus your second, your y now is 3. Then plus 3. Oops. Okay, so give me some few seconds and let me see if my way will respond accordingly. Okay, so it will be plus 3 times your first and the second. And your first element is minus 1 on 3. Then your second element will be what? 3. Okay, so here we go. So we are going to get in brackets minus 1 on 3. Then again in brackets what? 3. So now the bracket here will go minus 1 on 3. We are removing the bracket. Then again, you see, when you want to remove, check if you can, okay, cancel. And obviously, you can see that this 3 has a lot of options in terms of cancellation. It's either you cancel this and this, or you cancel this and that. Any of them will be okay, but you cancel once. So it will be minus 1 times minus 1 times 3. So that will give us minus 3 over 1. So we are going to get this here is subtraction. So let's see. You have minus 3 whole number. Then you have what? Okay, minus what? 1 on 3. So can I say that the answer will be the same as minus 3 whole number 1 on 3? Okay.
Mr.
Yes,
Hartman,
please. Yes.
Mr. Hartman, please, I've
Yeah.
made a mistake. Please, the rule says x plus y plus 3xy. And you've written negative 3, so where is the other 3 multiplying the xy?
Come again.
Please, the rule says x plus y plus
Mm-hmm.
3xy. But I
Mm-hmm.
didn't bring the 3, that was multiplying the xy.
I did. Okay, this is it. Look at it. It is, okay, what is your
But
x?
why?
What is
That's
your
why you didn't
x?
bring the Y.
No, what is your x?
Three.
Relax. What is your x?
-1 also.
Negative 1 on 3. Okay, what is your y?
3.
3. Okay, so it's going to give you 3 times x, which is minus 1 on 3 here, then times your y. So this is your x, this is your y. But the 3 is already there.
No.
It's 3.
Is
Mr.
multiplied.
Hartman.
Oh no,
Can you
the rule
read
is
it
what?
again?
The rule is x plus
3
y.
and 10
Yes.
Okay, I do get you. So I've
plus
left
3x.
out one of the terms.
Yes.
Okay, very good. Oh, you are right. You are right. I do get you now. You are right, my disciples. Okay, indeed. Okay, so I do get you. You are right. Okay, so I'm going to remove this one, clearing that. So then deal with it the right way. I think.
Mr. Hartman, you owe all of us chocolate.
Then it means I have to go and buy a chocolate factory. All right, okay, so this is it. Okay, so this will be equal to, sorry. So I'm going to 2. Your first one is minus 1 over 3, which is your x. Okay, then plus your y. Okay, which is what? 3 before this. So now I think I've corrected it. Is that not it? So it means this is going to go. Okay, so once that one cancels, we are going to get, okay, plus 3, then minus 3. So it means this and this will go. So you'll be left with minus 1 on 3. Is that clear? Okay, very good. So at this point, you draw your conclusion. So therefore, okay, what do we have? Okay, your minus 1 on 3 delta 3, okay, is equal to minus 1 whole number. Sorry, minus 1 on 3, forgive me. So as simple as that, this then becomes your conclusion. Are you with me? Okay, so once you were able to correct me, then it means my professors are indeed very obedient. That's why you knew the rule and you were following the rule. Okay, all right. Strictly.
Please,
Yes, please.
how can you add -1 on 3 and -3 without using like the LCM?
Okay, all right. So that like what I was doing initially.
Yes, please.
Okay, so this is what I do. If I have all my terms to be negative, then what I do is I factor out the negatives. I will get, okay, 1 on 3, then plus 3. Do you agree? If I had maybe minus 1 on 3, then minus 3. I can factor out negative. Then now I know how to sum. So if I sum, this will give me 3 whole number, 1 on 3. Then I attach the negative. But I do that mentally. Exactly.
Yes, please.
Okay, so you are fine. I can move on.
Mr. Hoffman,
Yes, please. But
please
that's
can
not
you
the
repeat
situation.
what you just said?
Okay, so I said, okay, anytime, you can easily add, okay, a positive whole number and a fraction if the fraction is positive and it is less than 1. So if I give you maybe 5 plus what, 1 over 3, you don't have to take the LCM. It's just 5 whole number, 1 over 3. You get the point? And just as I could do this for the addition, I can do same for subtraction. So if I have minus 5, okay, then minus 1 on 3. What I do is I forget about the negative because all the terms are negative. It's like I will, okay, factor out the negative. That's forget about the negative. Add these two mentally and attach your negative. So it will be 5 plus half, 1 on 3, which will give me 5 whole number 1 on 3. Then I just attach the negative.
Please, what if the fraction is negative and the whole number is positive? How
Yes,
are
so
you going to
it's
do
the
it?
same thing. Okay, this is what you do. Okay, now this is the same thing. This is what I do. Okay, only that will involve a little bit of thinking. So this is what you have. Okay, if what you have here is half, that's what half, you can easily deal with it. Immediately I see if this is half, I know that 5 minus half will give me 4.5. Is that okay?
Yes, please.
Okay, however, if it's not half, as for half and what have you, you can always deal with it easily. But if it's not what half, and it's maybe 1 on 3, okay, who can tell me the simple way to deal with it without using a calculator? 5 minus 1 on 3. Per the explanation that I've given so far. Wow.
Please, you can take 1 from the 5.
Very good. You
And that
started well.
one from the 5 is the same as 3 on 3. Then you subtract that minus 1 on 3 from the 3 on 3 to get 2 on 3.
So
Then
you
you
get
add it to the
4
4.
whole number 2 on 3. That's it. Perfect. Okay, so as simple as that. Exactly what I was going to say is what she has said. Okay, so what you do is you can see that this number, okay, 1 over 3, okay, is less than 1. So take 1 out of this. So if you take 1 out of this, you'll be left with 4. So it's like you've taken 1, you want to combine. So 1 is the same as 3 on 3. Okay, so you use the fraction. If this was over 4, then you would have used 4 on 4. So that your subtraction will be very easy. If this was over 5, then it will be 5 on 5. You get the point?
Yes.
Okay, so if you subtract the 1 from here, because this is 3, you subtract 1 because they have the same denominator when you are combining. So you deal with the numerator to be 3 minus 1, which will give you 2. So now you come and add the 2 on the 3 there, as simple as that. So irrespective of how it is when your other fraction, let's say the fraction is maybe 5 on 2 or 5 on 3, you can see that this one is not less than, okay, 1. So in that case, you have to write this one as 1 whole number, okay, your 2 on 3. Then you go and add this whole number to the other whole number. So let's say if I have this, then plus 5. I'll add this whole number. So that will give me this whole number, then your 2 on 3. Is it 2 on 3? Yes, 2 on 3. As simple as that.
Please, can you come again?
Anyway, so now I'm veering off what I am doing. Okay, so let's stick to what we are doing. As for this algebra, in due course, we'll look at it. Okay, it was your JHS teacher who was supposed to cure this, how to work with fractions. Okay, however, where at this point, I've told you, if you have to take the LCM, take the LCM, you go. If you can't do it mentally, take the LCM, because you know that's the other way to go. But in due course, because immediately I zoom into this, okay, okay, I will not finish what I'm supposed to do today. So if you get the understanding for this, as for the algebra, we can always work on it. So take notes. All right, so now let's look at the next one. Okay, the I. So this will be equal to, do we have to do this one? Try, then let's see. Okay, so let's try. Okay, let's do this one, then I'll give you another one. Let me see the next one. Okay, the next one will involve two fractions, so I'll see how you can deal with that. So let's deal with this one together and see. So remember, the rule says, okay, you even had my attention drawn to the proper rule. You said your first, which is 3, plus your second, which is minus, okay, 1 on 3. Okay, then plus 3 times your first, which is 3, times your second, which is minus 1 on 3. So again, this will give us 3 minus, because plus and minus, if you are going to get, okay, 1 on 3. Then this, don't multiply, reduce if possible before you multiply. The 3 here can cancel this 3. So you'll be left with this times that, which will give you minus what, 3. So in effect, you can see that you are going to get 3 minus 3, then that will give you 0, then your minus 1 on 3. So you'll be left with, okay, minus 1 on 3 as well. So therefore, your 3 whole number, 3 delta, forgive me, minus 1 on 3 is equal to minus 1 on 3. Is my point well made? Okay, all right. Okay, so let's see how you can deal with this before we do the next one. So I am going to, okay, pause recording. All right. Am I right? It's my presentation.
Yes.
Okay, so here, so your first plus your second plus 3 times your first times your second. Okay, and you know that this is negative, negative. So when you multiply, here you can reduce. The 3 can cancel, the 2 can cancel. So you can do two-way reduction. Then after that, what do? This is what you'll be left. Come and take the LCM because they are not directly the form that you can mentally add. So just take the LCM, then work with it. Thankfully, what you have there, okay, what do we have? We already have a proper fraction. So you go and draw your conclusion. Therefore, never forget your conclusion. Minus 2 over 3 delta minus 3 on 2 is equal to 5 on what? On 6. Is my point well made?
Yes, please.
Okay, please, who didn't get what we have here? Reina.
Mr. Hartman,
Mm-hmm.
is the minus affecting the numerator and the denominator?
Is what?
Is the minus affecting the numerator and the denominator? The
No.
negative.
Whenever you have a negative, the negative is either affecting the numerator or denominator. It cannot affect both. If it's affecting both, then it's supposed to be positive. Because if I have a fraction where the numerator is negative and the denominator is also negative, I will end up getting a positive result, not a negative result. You get it?
Yes.
So anytime you have negative attached, if you see minus a over b, it's either the negative is coming from the numerator or it's coming from the denominator. It cannot come from both.
Mr. Hartman,
Yes, please.
is 3 times negative 2 out of 3. So how did the negative 3 out of 2 cancel that one? I mean, the 2, one is negative and one is...
No, you can see that this one, the 3 cancel the 3 here. Is that not it?
Yes, please.
The 2 also cancel the 2, so you are left with negative 1 in the numerator. But negative will come and multiply this negative and become positive.
But Mr. Hartman, the 2.
Which 2?
The 2.
So it's just like,
they are negative.
if you have minus 2 on 3, okay, then times, okay, 3 on 2. Okay, you can see that this will cancel, this 2 will cancel, leave the negative there, it's alone. This will also cancel, so the negative is there. So it will be negative 1 times 1, which is what? Negative 1, then over 1 times 1, which is 1. So you end up getting negative 1. You get it now?
Yes, please.
Great, all right. Okay, so I think I've seen other hands up. Reza, were you the one who...
Yes, please.
Okay.
Mr. What if we are changing mixed numbers into improper fraction? Does a negative affect the numerator or the denominator?
When you are changing what?
A negative mixed number, like -1 over -1 whole number 1/3.
Oh, remember I told you, keep the negative. Deal with this one as if you are dealing with positive. So it will be 3 times this. Okay, negative, you have negative a. It means I have a, then I have negated. So I can still work on my a, then negate it. So negative this means I have this positive value, then I have negated. So let me work
No,
with this
please,
one as if.
no. I'm asking whether the negative will affect. You said a negative cannot affect both a numerator and denominator.
Uh-huh.
So I'm asking whether when you change a negative mixed number into an improper fraction, whether the negative affects the numerator or the
No, it can.
denominator.
Once you have negative there, unless I tell you, you know how this was, okay, arrived at. You cannot tell whether this negative came from the numerator or the denominator. All that you know is that it came from one of them. So if let's say I have negative, let's say 2 over -3, and I come and write this one as maybe -2 on 3. I know where I was coming from, so I know that this negative came from, the negative that I've written here came from the denominator. So I know this negative where it came from, because I know where I came from. You get it?
Yes, please.
However, if you don't know this, and I write this one there, you wouldn't know, because this one can also be the same as what? The negative came from the numerator. So if I just give you this, you wouldn't know where the negative here came from, whether it came from the numerator or the denominator. So if I have negative here, until I give you enough and sufficient information, you wouldn't know where this negative came from, whether it came from the numerator or the denominator, after expressing this as what? Its corresponding improper fraction. So if I write this one as maybe 4 on 3, -4 on 3, okay, the negative is there. This negative, we know, all that we know is that it's possible it came from the denominator, or it's possible it came from the numerator. But I know it cannot come from both. But I'm not sure which one it came from. You get it?
Yes, please.
Okay. Are you sure my point is well made?
Yes, please.
Great. All right. Okay. So at this point, now let's go and look at this situation. Gradually, we are building our points to what lies ahead. Okay. So in this case, it's the same scenario. Okay. This time around, we are going to work with what we have in brackets. And let's see. Usually, like I told you, check whether you've done, okay, what you have in brackets in the same question. Okay, but I don't think so. We have not. So let's see whether we've done it in the same major question. Okay, let me see. Yeah, I think we have. Yeah, we did it in AI. Have you seen that? What we have here is the same as this. And what did I say you can do in such a situation once it's from the same major question?
You said you can substitute the answer into.
Yes, you can infer and substitute directly, but that one comes at a risk. Okay, and who can, I want someone to tell me the risk that I told you about if you go by that approach. That's the ideal approach to go anyway. Okay, you don't stress yourself twice for the same work once it's in the same major question. Okay, what would be the risk if you infer? Hello, are you there? Okay, so,
Yes.
Akosia,
Mr. Akman, please, I think if you had the answer for the first one wrong and you infer, you're going to get this one too wrong.
Very good.
That's the
So
risk.
that's the risk. Okay, but we know we are good, so we get the first one right and get the second one, okay, equally right. So if the first one is wrong, then now it becomes garbage in, garbage out. So be very careful. Thank you, Akosia. So at this point, we can infer. What did you get for the 1/2? Okay, then what's that at 2?
11/2.
Okay, remember it gave us what? 5 whole number 1. What was it? Yes, 5 whole number 1/2. Okay, Okay, so that was our conclusion. When you are inferring, okay, and you want to carry out the substitution, substitute for its corresponding, okay, improper fraction. Don't substitute the mixed fraction one. Other than that, you have to go and change the mixed fraction to its corresponding improper, and then you move on. Is my point well made? So 5.5, we know, is the same as what? 11 on 2. So this is 11 on 2 delta 1. Okay, because we've done this already. So now, what do? We know delta, it means the first, okay, it says the first, okay, plus what? The second, then plus 3, okay, times the first, which is 11 on 2, then times the second, which is what? 1. So in this case, you get 11 on 2 plus 1. This one you can't cancel. You can only multiply. So you get plus 33 on 2. So at this point, you are in a comfortable lead. Okay, if you want to use your calculator, it's allowed. Okay, otherwise you take the LCM, then you move on. So I'm waiting. Okay, we can equally do that mentally. This will give us 5.5. Am I right? Plus 1. The other one will also, I'm doing it mentally. This will give us what? What and half?
16.5.
Okay, so that will give you 16.5. Okay, so it means the whole numbers we are going to add. Okay, 5 plus 1, which is 6. Okay, plus 16. And that will give us 24. Am I right? So it will be 24. Am I right? But plus the half, it will give us 1. So it will be plus 1. So we are going to get 25. So what we have here will give us 25. Otherwise, you know what to do. Take the LCM, then move on. Which one is 23?
Mr. Hackman, please, it's
Yeah.
93.
Oh, let me see. I did what? 5 plus. Okay, so let me come again. 5 plus, this is 6. Okay, plus, what do you call it? 16. Okay, so that will give us what? 22. Okay, so this will give us 22 in the stead. Okay, then it will be half plus half, which is what? 1. So it will be 23. Okay, you are right. Very good. Okay, so you are right. So 23. Is that clear? But remember, I've told you, you should avoid deepening. So you are supposed to cancel it and write it again. Cancel it and write it beside it because you've not exhausted using the line. Okay, is that clear? Then don't forget your conclusion. Your conclusion must always come. So therefore, yes.
Please, why was the 2 used to multiply only the 11?
Come again.
The 3 times 3 was why was the
Yes,
2
the
used to multiply?
numerators will multiply numerators and denominators. You can, if you have A times what? B over C. Are you trying to tell me that this will be equal to A, B, then over AC? You multiply this one to the numerator and come and multiply this one to the denominator. If you say yes, then I have to come to your house, take you to your JHS teacher. The person must refund some of our fees. You get it? So this is a numerator. This equally is a numerator. So the numerators will multiply. So it will be 3 times 11 times 1, which will give us 33. Then this is over 1. 1 times 2 times this is also over 1. So you get your 2 there. So the only denominator here is 2. So when you multiply, that becomes automatically the denominator. Is that clear? So this one rather is equal to A times B, which is AB. Okay, it will not multiply the C. Okay, numerators will multiply. Okay, and denominators will also multiply. So numerator will not come and multiply numerator, and numerator will come and multiply denominator. No, when you are multiplying, I told you this when we were doing the order of operation. Okay, numerators multiply numerators, denominator multiply denominators. They cannot cross. It's when you are reducing that you know what to do. Numerator will reduce denominator. Is that clear?
Yes.
Great. Okay. I saw another hand up. Oh, you are fine now.
Yes, Mr.
please. When I used the LCM, it was like I was getting a different answer. So please, can we solve this using the LCM?
No, you shouldn't get a different answer. If you want us to solve the LCM, tell us. If you can't solve this by the LCM approach, okay, then tell me the school that you went so that I won't take any of my words there. Okay, anyway, if you want us to do it. It's nothing difficult. Okay, so this is what we have. Okay, all right. So let's go. Okay, those of you who are through, okay, and waiting, please try this one. Is that okay? Okay, so try this whilst I am explaining that to her. I'm coming. Should I go back?
Yes, please.
Okay, I'm coming. I'm coming. Okay. It's the same question, okay, as the first one, but the last two in brackets. Is that okay now?
Yes.
Okay, so I think so when you take the LCM, my good friend, this is what is going to happen. Let me know your name. Who was that? Kelly.
Yes.
Yo, now we know you. Let's go. So this is what we have. Okay, so LCM, what will be your LCM? Is it not 2?
Yes, please.
Okay, now this will be over 1. So you ask yourself, 2 will go into how many times? It will be 1 times 11. So it will give you 11. Then plus 1 will go into 2 how many times? 2 times 1. So that will give us 2. Then plus, okay, 2 will go into this how many times? It will be 1 times 33. And that will still give us 33. So in effect, we are going to get what? Okay, your denominator will be 2. Your numerator will be 33 plus what? This will give you what? 35, am I right?
Yes.
So plus 1 will give you 36, then plus 10. Because I broke this one down into, okay, 10 plus 1 to make my addition very easy. Or 11 plus 2 is what? 13. Is that
Okay.
Oh,
See now.
Jawasam kra. Jawasam kra. You've not been a good ambassador of your school. All right. Okay, so now let's go to this. Okay, so those of you who are done with this one, you can cross-check now. Okay, so this will be equal to, you keep the half, okay, your delta, then what do? We come and work on this. Unfortunately, this one we've not done, so we have to, we've done it. I don't think so. So we have to go and use the rule. Your first plus the second, then plus 3 times your first, okay, times what? The second. So which gives us what? 1 over 2 delta. Then this will give us what? 2 plus 1. Then this, if you multiply, you get plus 6. So in effect, we are going to get half delta. If you combine it, this will be 9. So 9 is just a single. You can now ignore the brackets. Okay, Blaze.
Please, I got the same answer for I.
For I. You got the same answer for I. Okay, that's what you are supposed to get. And in any case, it's giving us a certain, yes, it's giving us a certain information.
Yes, please.
Okay, so let's do it together. However, I'm not only interested in the answer, I'm equally interested in the process that led you to your answer. So now what do we have? We are combining 2 elements under delta. So that will give us our first element, which is half, plus your second element, which is 9, then plus 3 times our first element, which is what? 1 over 2, then times our second element, which is 9. So in effect, we are going to get 1 over 2 plus what? 9. Then we check if you can reduce. Unfortunately, we can't reduce, so you need to go and multiply. So plus 9, 3 times 9, that will give us 27 over what? Over 2. So what do? Assuming we've exhausted our main work area, fortunately, we pushed our work here, so we have room here to continue. So that will give us, okay, we'll take the LCM. Or if you like, those of you who will not take the LCM, okay, we will have 27 on 2 will give us what? What and half?
13.5.
So 13 and a half. So you keep the half. So the half plus half here will give you what? So you have 14. 14 plus 9 will give us what?
23.
23. So we end up getting 23. Otherwise, you take your LCM, then you move on. So you draw your conclusion as well. So this is telling us, giving us a certain information about the nature of your operation. Okay, so very soon you will know. Okay, so at this point, what do we have? You draw a conclusion. Therefore, half delta in brackets 2 delta 1, okay, is equal to what's 23. Point well made. Okay, so, okay, I want you to do this for me whilst I'm waiting. Okay. There is no need. Okay. All right. So here, this is what you are supposed to do. You know how to evaluate. We did the vein. The vein gave us what we have here. Okay, obviously. Okay, now we are looking at the vein is up there. Okay, so the vein gave us this result. Okay, and we are now looking at what? The VI. So you know how to evaluate. So the same. So you just look at the question asks you to draw your conclusion from your result in V and VI. So V gave us what? 29. And we also realized that VI, okay, gave us the result 29. But if you look at what we have in V and VI, if you go to the question itself, you see that V, let's look at the elements, 3 elements, 2, 4, 1. 2, the VI, 2, 4, 1. Immediately you have 3 elements. You are comparing 2 results with 3 elements. Commutativity is out. I've told you that. So it means here the only way out will either be associativity or distributivity. However, you know for distributivity, you shouldn't have the same operations involved. You should have 2 operations, but different operations. But here we have 2 operations and same. So it means commutativity is out because the elements more than 2, and distributivity is out because the operations the same. So if this result gives you the same result as this, then you can say that your operation is what? Associative. And you give your reason. And your reason being that the result here is equal to the result here. So that would be it. And I was just making a point that if maybe you saw that this was 2, 4, 1, and what you were also going to compare, you have 3 elements, but it's 2, 4, negative 1. Remember, for you to talk about associativity, your numbers involved, they should have the same reading, the 3 numbers. Only that you group the first 2 and the last 2. So if the readings are not the same in terms of your numbers, okay, and you have grouped the first 2 and the last 2, just because your readings are not the same, you cannot talk of what? The associative property. So in that case, assuming the numbers were not the same, and you ended up getting the V result to be the same as the VI result, then your conclusion, okay, can only be this. Okay, you just have to write, therefore, this result, which is the first result that you had, is equal to this. You cannot mention associative here. Because remember, I've told you, when the numbers are not the same in that particular order, then it means you cannot talk. So in that case, your conclusion will be therefore this is equal to that without saying your operation is associative. I guess my point is well made now.
Yes.
Okay, so now let's go and look at our next set of questions.
Mr. Hackman,
Yes, please.
please. So if the first side, let's say the left hand side, like the same example you gave, the other side was -1. And what if you get different answers when you solve?
No, if you get this different idea, you just have to write, therefore this is not equal to that. That's all. You get it?
Yes, please.
Okay, however, if they were in the same order, with the same numbers, and this is not equal to that, you will start by saying, therefore, the operation is not associative because you could see associative property involved. Then you come and say, therefore, the operation is not associative since this is not equal to that. But with the other one, because associative property was not involved, this will be out. So it will be left with your reason, which now becomes your conclusion in that situation. You get it?
Yes, please.
Great. All right. Okay, so let me see if we can, okay, try a bit of what the, okay, so this one, okay, is what has one with the, okay, so let's look at what we have here, okay, and see how best we can deal with what the I and I and draw our conclusion. Then maybe I will leave you, okay, I will leave the I and the IV with you to try. Okay, then maybe we'll look at it in our next meeting. So let's look at question 2. So let's see. So here, okay, let's see the number of operations. The binary operations, star, circle, dot, delta. So we have 3 operations are defined on a set of real numbers. So it means all the operations are defined on a set of real numbers. So defined on a set of real numbers. Is my point well made? So you underline that. So we are going to extract all the operations here with their rules. So solution, this is what you write. So question 2. Okay, so the question, the information that you are picking, you picked it from the 2. The question number attached to that information is 2, not 2 alpha. It is really 2. So you have 2. Now let's see. Okay, do you see any vital information missing in our extraction?
Yes, please.
What is missing?
Where A, B, and A, B, X, Y, P,
Very
Q,
good. So
R.
here, don't come and write. Don't write maybe A, B, then you come and write comma. So put all of them together. So comma, you know, your letters involved will be A, B, X, Y, then P, Q. So you write A, comma B, comma P, or X, comma Y, comma P, comma Q, belonging to what? A set of real numbers. Is my point well made?
Yes, please.
Okay. Other than that, if you take each one and write A, B belonging to a set of real numbers, this belonging to a set of real numbers, this, you will see that you write, okay, more. Because you write belonging to a set of real numbers how many times? 3 times. Meanwhile, you've been able to extract that same information, writing the set belonging to a set of real numbers only once, putting all your elements words together. Is that clear? Okay, so now let's go and look at I. Quickly, we'll finish very soon. Okay, just some few minutes. So 4 circle dots. Now you are looking at combining these 2 elements under, okay, delta. So it means you restrict yourself to delta. Please take notes. So for delta, this is the rule. You are supposed to get a fraction. In the fraction, the numerator, it is minus. So you can see your first element minus your first element. So minus my first element is what? Minus 6. So I put it in brackets. Very critical. Over your second element. So the denominator is what? Your second element squared. Now what's your second element? Your second element here is minus 2. So you put the minus 2 in brackets, then you squared. But that's not all, plus 1. Should I come again?
Yes, please.
Okay, you are going
Yes.
by the rule. The rule for delta means I will get a fraction. In that fraction, the numerator is minus my first element. And the denominator is my second element, which is q squared plus 1. Is that clear? Okay, so it's like minus first, okay, over second, okay, squared, then plus 1. Is that clear? So anytime you are substituting your elements, put it in brackets, remember. So minus, what is your first element here? If you combining this, it's minus 6. Your second element is minus 2. So minus in bracket, your minus 6, which is your first element, over, okay, your second element, which is minus 2. You put that in brackets. Failure to put it in bracket, the meaning will change. Okay, squared and plus 1. So now you are going to get 4 circle dots. We are coming to simplify our fraction. And here I didn't put this in brackets because I realized that this is a single fraction. It's just a term. So brackets will not be necessary. The whole of this is a single fraction. So I will get minus minus 6, which will give me 6. Then over minus 2 squared, and that will give me 4. Then plus 1. So it means in effect I'm going to get 4 circle dots what? This will give me 6 over 5. Do you agree?
Yes.
Okay, remember you are not drawing your conclusion with this, so you don't change this one to miss numbers. You continue. Now you are combining these two elements under which operation?
Circle the 12.
Okay, so you go to the circle dot operation and its rule. And the rule for circle dots is you should get a fraction. In that fraction, the numerator is your first element plus your second element, and your denominator is 3. So the 3 doesn't involve your element, so you just write it there. The numerator, first element plus second element. So what's your first element here? 4. Plus your second element, what's your second element? 6 over 5. Do you agree?
Yes, please.
Okay, so you are just following the rule. So you can see that gradually what mass is coming in play. Okay, so at this point, what do we do? This will be equal to, our numerator should be expressed as a single fraction. Then the denominator is already a single fraction. Okay, so the next step, you express this as a single fraction, you take the LCM. Immediately you are taking the LCM and this already, then you can change the bar. Remember what I told you, to the symbol, the division symbol. So over 3. Then now this becomes what? My LCM will be 5. Okay, this is over 1. Okay, 1 goes into 5, how many times? And that will give you, 5 times 4, so I'll write 20. This is not order of operation, so if you can get the value, write it there straight away. So this 5 will go here 1 time, so that will give me 6. So if I continue, this is going to be my continuation. So I'm going to get this to be equal to, 20 plus 6, which will give me 26 over 5. Then divided by 3. So in effect, I'm going to get 26 over 5, then times 1 over 3. Do you agree?
Yes,
So I'll end up getting, remember, can you reduce? No.
please.
So you multiply numerators. So 26 will multiply the numerator 1 here, which is 26. 5 will multiply the 3 here, which is what? 15. But unfortunately, you cannot conclude with an improper fraction, so you have to change. But I will do the change in my conclusion. Therefore, 4 circle dot what? Minus 6. Data. Minus 2. Will be equal to. Let's change this. 1 whole number.
11 over
Come again.
11
over 50.
Okay, so this then becomes your conclusion. 11 over 15, 1 whole number. Is that clear? Okay, so this is what you are supposed to do as your assignment and submit. Okay, because of time. You are doing the II. You are doing the II. Okay, then you use your result here and the previous result, which is the I, to draw your, so you do beta, so you do beta A. So you are doing this one and the beta A. Is that clear? We've done this together. And here you can see that how many elements involved? How many elements? 3. 1, 2, 3. Okay. How many operations involved?
2
Are they
operations.
the same or different?
Different.
Okay, so it means although you have 3 elements, you cannot talk about associative property because the operations are not the same. So let's see whether in what you have there, you are distributing this. So you can see it is 4 circle dot minus 6, in one bracket, then delta 4 circle dot minus 2. So it means that I and II is talking about the distributive property. Is that not it?
Yes, please.
So you use your result here together with what we just found to do the alpha for me, the beta A for me. Is that clear? So do this and use that one to draw your conclusion and submit. Okay, if I'm not able to mark, I will definitely go through, but I'll try as much as possible to mark. Okay, is my point well made? Okay, so please take note. That will be your assignment. Okay, so
Fine.
any questions? Yes, before I move on.
Please put the solution for the alpha I.
The alpha I.
Yes, please.
I should what?
I want to screenshot the solution.
Okay, this is it. I was going to work on it and put it on the platform. Is it okay now?
Yes, please.
Okay, all right. So that's it. So you do the other one to then later. Okay, you draw your conclusion. Okay, and submit. Okay, Elena.
Mr. Hackman, please, you said when we are drawing our conclusion in distributive property, would one operation will be over another operation.
Will be what?
Over another operation. You said
Will be what?
distributive.
I want you to use the right word. One operation distributive over another operation.
Yes. So, Mr. Hackman, what you said when we conclude, we don't get any operation. So how will we know the operation that will be over the that will
Oh,
be
I
over
told you just the first operation. Okay, this is it. I told you that. Maybe you didn't listen. Okay, I told you you could see. Okay, two operations here. Which one is the first operation?
the delta?
Okay, I mean, let me restrict myself. I will use this. I don't want to answer this one for you, but I want to use this. Is that okay? So if you take the I, okay, the first operation is delta. The second operation is what? Circle dot. So it's the first operation that you will distribute over the second operation. So if the two results are the same, then you say the first operation, which is therefore delta, is distributive over circle dot. Since, okay, even if you come here, you see that the operation that appears most here will be the one that you distributed. And if you come here, which operation star is circle dot is appearing once, delta is appearing how many times?
Twice.
So it means it was delta that was distributed. Okay, all right. Okay, so I think that will be it. Okay, for today. I've taken 10 minutes of your time. Okay, please forgive me. All right, so it was for a good cause. Okay, so thank you very much. Okay, I think it's been a successful class. You agree?
Yes, please.
Okay, good.
Yes.
All right, you are doing well. Keep it up. Yes, please.
If
Hello.
the solution,
The solution for.
Mr. Hartman,
Mhm.
I please help you how to answer the question.
You want to write the previous solution? Did I get you right?
Yes, please. Step one, I don't get how you got the negative into bracket next 6.
This one. Unfortunately, I can't go over because remember the rule at the point
Yes,
that you
step
didn't get.
one.
At the point that you didn't get, you should have drawn my attention. Unfortunately, I will go over. So what will happen is wait for the video, watch the video. If it's only that part that you watch, then you continue. If you understand everything, I can't go back, unfortunately, because I've told you, number one rule, at the point that you don't understand, let me know. Don't let me, okay, struggle to this far or move to this far, then you take us back. It will not be fair. All right. Okay, so wait for the video, you get the explanation, then you move on. And please take notes. I think at this point I have brought the curtains down, but don't leave. Okay, all right.